Video number 3, section 14.2, inference for two-way tables, where we compare sets of observations with a set of expectations. In this video, we will be doing a chi-square test for independence. So let's get started. Before we get started though, let's remind ourselves it's very important for you to distinguish between these two types of chi-square tests that involve two-way tables. I want to make sure that you know the difference between tests for homogeneity and the test for association and independence. When you're dealing with homogeneity, you're trying to compare two or more populations to see if they have the same proportions for one categorical variable. When you're dealing with a test for independence, you are taking a sample from a single population and you are trying to determine whether or not two categories are related to each other. In the chi-square test for independence, we will follow the four-step procedure just as we did with the test for homogeneity and also the test for goodness of fit. We will begin by stating our hypothesis, and in this case we will be saying within the context of the problem that the two variables we're looking at are independent as our null. We will start out by assuming that, and we will gather data to prove or gather evidence in favor of the alternative, saying that the variables are not independent or related. Same thing. In step number 2, you're going to want to report what kind of test you are running. In this case, the test for independence, and of course the conditions that allow us to run that test. And here are the conditions. We want to make sure that our sample is a simple random sample from our single population, and all the individual expected accounts will be at least 1, and we want to make sure most of them are 5. No more than 20% of them should be less than 5. We will be using this formula, the same formula we use for a test for homogeneity, to figure out all the expected counts. In step number 2, it's important that you make sure you state what test you're going to be running, and then also state the conditions that allow you to run this test. We do want to make sure that we take an SRS from the population in this case, and we want to make sure that all of the expected counts are at least 1, and most of them are greater than 5. No more than 20% of them should be less than 5. We will be calculating our expected values based on this formula right here, taking the row totals times the column totals and dividing them by the sample size. Now of course you'll be running these tests on your calculator, and when you do run the chi-square test, the calculator will calculate all of your e-values. Again, the chi-square statistic is calculated using this formula right here. You should be familiar with that formula. It is on your AP formula sheet. You will have to know how to calculate the degrees of freedom for that test statistic. You will find this on your calculator when you run the chi-square test, but you should make note that this is the formula that is being used. You'll also be told the p-value when you run the test on your calculator, but you should be familiar with the table, the chi-square table that allows you to find the p-value that corresponds with your test statistic, and you should also be aware of the fact that we do have chi-square CDF on our calculator. Your test statistic chi-square would go first, and this is right tail, so 999 or infinity, and then also the degrees of freedom last. And finally, you'll be stating a conclusion about your test within the context of the problem. You will be rejecting if the p-value is lower than a stated alpha. You will be failing to reject if the p-value is greater than a stated value. So here's our second example for inference about a two-way table, and this will be a test for independence. What we have here is a company by the name of Innovative Machines Incorporated. They have developed a new letter arrangement for computer keyboards, and they want to know if their arrangements are related to the time it takes to learn how to type 20 words per minute, for a new student, that is. And we want to know how to exactly state the null hypothesis when we're dealing with this test for independence. So we're looking at a relationship. We're trying to prove that there's a relationship between the keyboard arrangements and the time it takes to learn. So we'll start out by assuming that there is no relationship. We're going to say that they're independent of each other. So we'll write arrangement of keyboard can't spell today, keyboard and time are independent. I'm being a bit brief on my explanation here because I don't have much room to write. You would want to be a little more expansive in your interpretation here. The alternative, what we're gathering data for, is to suggest that the arrangement of keyboard and time to learn are not independent, which means they're related. So here you see we do have the sample data gathered for a number of students who are trying to learn these various keyboards, and this would involve us making sure that we put all of this observed data into a matrix in our calculator. And then once we have it into our calculator as observed data matrix, then we will run the chi-square test for independence, and it will produce all of our expected amounts. Remember, so finally, in step number 4 here, we will write a conclusion based on the decision we're going to make from our p-value. We know that our p-value is very low, so that allows us to reject the null. Remember, the null says that the arrangement of the keys and the time that it takes to learn are independent of each other. There's no relationship. We're going to reject that idea, and we're in favor of the alternative based on our evidence of a very low p-value of 0.0099. So our conclusion would be we have significant evidence that the type of keyboard arrangement is related to the time it takes to learn it. And of course, learning it means typing 20 words per minute. Oops, I need that. So there we have Nice example of the test for independence. Chi-square test for independence, very similar to the test for homogeneity as far as how we calculate the chi-square and the p-value. However, the wording for this type of problem is quite different than the test for homogeneity.